Hi everyone, today I've got the Edexcel 2023 A-level paper 1. Let's get to it. So question 1, we're looking at integration and we're looking at polynomial integration. So when we're dealing with polynomial integration, what we're trying to do is we're trying to express all of the x's in terms of their powers. So if you look at the numerator, we have x to the half, we have x to the 1, right? So plan is if you expand all of this, simplify it, and get everything in terms of powers of x, we can very easily integrate. So if I do x to the 1 plus x to the half, I get x3 over 2 minus 5 times x to the half over 3. And that is dx. Now what I'll do is I'll actually take the 3 out as a constant, the 3 in the denominator, so I get a third 2x3 over 2 minus 5x to the half dx. And now I'll actually integrate. So when we integrate in polynomials, what we try to do is we add 1 to the power and we divide by the new power. So if my power is 1.5 or 3 over 2, I add 1 to it, I'm looking at 2.5, which is 5 over 2. So 2 times x, 5 over 2. Now divide that by the new power, which is 5 over 2, and we'll deal with this, and I'll show you a little trick of how we can do this a bit faster as well. But for the sake of it, I'm going to go a bit slower. So that's 3 over 2 over 3 over 2. And don't forget plus c because we're dealing with an indefinite integral. Now let's actually simplify all of this. So what we'll do is we'll do the keep change flip method when it comes to any sort of fractions in the denominator. You can go over the long way, but effectively what you've got is if you've got a fraction over a fraction, the denominator comes on top. Again, if you want to prove this, that is the case, you can look to do so from using KCF, keep change flip. But if I were to do that, I get is 4 over 5 x 5 over 2 minus 10 over 3 x 3 over 2 plus c. And finally, I'll just times everything by that third that I've got a constant. So that's going to give me 4 over 15 x 5 over 2 minus 10 over 9 x 3 over 2 plus c. And that is my final answer. Nice. So let's move on. Next question. Okay, looks like a factor theorem question. We've been given a factor of this equation and we're asked to show that this is some equation. Now, my first instinct here would be to use factor theorem and say if x minus a is a factor, then x equals a must be a solution. So then I'll sub it into my function and hopefully I come out with whatever we're looking for. Okay, so I can start off with saying if x minus a is a factor, then x equals a is a solution. And I'm going to just write the shorthanded. So f of a is equal to 4a cubed plus 5a squared minus 10a plus 4a. Cool. Now what? So now we can say that because it is the solution, we expect f of a to be therefore equal to 0. So I can clean this up furthermore. This would give us minus 6a. And finally, I can take out a as a common factor. I get 4a squared plus 5a minus 6. At this point, you can actually solve this quadratic using whatever you want, but I guess that will be part B. But for part A, we got exactly what they wanted us to show. So I can say QET. It's just a Latin way of saying you proved something. I actually can't remember what the actual whole thing is. But okay, all right. Now part BI is asking you to find the value of A. So we got a quadratic. If anything, we got a cubic here. One of the solutions is 0, but the other quadratic, we're expecting to see 2 solutions. But the question's saying 1 value. So we need to figure out which one we're going to take. Like I was saying, you can use a quadratic formula, whatever, or factorization, up to you. Since you get a calculator that you can use, we'll be actually using the calculator. So we want to go to the equation, polynomial, second order. Our equation is 4 5 and minus 6. So that gives me as my first solution, sorry, so I get a times 4a minus 3, and my next one is a minus 2 equals to 0. So therefore my three solutions is a1 equals 0, or a2 equals 3 over 4, or a3 equals 2. Okay, now they want the value of a, and we can see that a is a positive constant, so therefore a must be equal to sorry, that was minus 2, right? That was minus 2, so a must be equal to 3 over 4. So therefore a equals 3 over 4, and that's because a must be greater than 0. Now, the second part of the question says, use algebra to find the exact solution to the equation where f of x is equal to 3. Okay, so now that we know what the value of a is, which is 3 over 4, we can sub that value in here so we can find what the actual equation of f of x is. Sorry. So this is part 2. Our f of x is now equal to, come down here, I've got 4x cubed plus 5x squared minus 10x plus 4 over 3 over 4. So that simplifies to give me plus 5x squared minus 10x. So 4 cancels out to give me plus 3. And this is equal to 3. I can cancel the 3's out. I get 0 equals 4x cubed plus 5x squared minus 10x. Again, I'm going to take a x out because it's a cubic. So I can take an x out to give me 4x squared plus 5x minus 10. And I'll just hop on to my calculator again. And I'm going to say I've got is 4, 5, and I have minus 10. Okay, cool. Right, looks a bit horrible, but we move. So x1 is equal to 0. x2 is equal to minus 5 plus 185. Over 8. Actually, I'm just going to say x2 3, and I'm going to just stick a plus and minus in there. Cool. Is that all they wanted? Okay, that's all they wanted. They wanted the exact solution. So actually, yeah, we getting something funky probably is right. Okay. Okay, next we've got position vector A, position vector B. We want to find the magnitude of the vector OA and show that that is root 38. So in this case, this is pretty trivial. All we really asked to do is find the magnitude of the vector A, because the vector A is with respect to the origin. Okay, so what we're trying to do therefore is O to A is going to be equal to 5 squared plus 3 squared plus 2 squared. That's 25, 34, sorry, 25, 9 and 4. That should give you root 38. Cool. Part B. So now I want to find the smallest value of A for which the magnitude of B is greater than the magnitude of A. Okay, so we can just set up two equations. On one side we'll have the magnitude of B, and the other side we'll have magnitude of A, and hopefully we'll solve it out so that we find what the smallest value of A needs to be. A being one of the components in the B vector. So what do we have? So we write down the equation that we're going to be using. O to B is going to be 2 squared plus 4 squared plus A squared, and that must be greater than root 38. At this point I can just square both sides to get rid of the square root. So I get 2 squared, that's 4, 16, so that's 20 plus A squared is greater than equal to so greater than 38. And then I can just take away the 20 to get 18. So now what I'm trying to say here is that the A squared, the square of A, is greater than 18, and we're looking for presumably an integer as well, integer value of A. So clearly, if I think about my square numbers, 4 squared would give me 16, which is not greater than 18. I guess the next one then, 5 squared, which is 25. So therefore A must be equal to 25. Sorry, A must be equal to 5, which is squared 25. Right, what do we have next? Okay, so we've been given the derivative. Alpha is small, so small angular approximations. There you go. For cos, to estimate the value of alpha. All right, so let's get started. So you are actually given all the small angle approximation in your formula booklet. So if I head out to the formula booklet, we are looking for small angles. There you go. So there's the small angles. So what I usually recommend when you are doing past papers, always have your calculator, but also have your formula booklet uh, at hand. So you can actually check and cross-reference and see what's in the formula booklet, because this will be given in the exam when you head out for your actual exam. So we're looking for cos, and we have the cos small angle. So we have that cos theta is roughly equal to 1 minus theta squared over 2. Okay, so let's come back to what we were actually trying to do. So f dash x is going to be equal to 2 alpha plus a half of cos, which is 1 minus alpha squared over 2. All right, and let's simplify this. So I get 2 alpha plus a half minus alpha squared over 4. Now, because we know this is the stationary point, and at stationary point, well, your gradient is equal to 0, so we can say that that's equal to 0. And I should also, to be completely right, I should say alpha there. So we can just times everything by 4 here to give me 8 alpha plus 2 minus alpha squared, right? Yeah, same old. I'll just go back to my calculator at this point, and I'll say I've got is minus 1, I have 8, and I have 2. Okay, so alpha, therefore alpha 1 and 2 is equal to, actually let's actually check the values, and let's slow down and go one solution at a time. This is 8.243. we're on 3dp, right? Yeah, 3dp, and alpha 2 is equal to, hopefully a small number, there you go, 243. And remember, we're looking for a small angle. 8 something radians is not small, right? So don't get carried away when you see a negative and you start thinking, oh, right, can I have a negative angle? Absolutely, right? We are ultimately looking for something that is a small value. We're not looking for something strictly positive. So alpha in this case would be minus 0.243. Next we have is the point, that's the y-intercept, by the way, on C. Find the equation of the tangent at point P. Alright, sounds good to me. So now, first thing first, if you're looking for the gradient of the tangent, we have the gradient function, which is your first derivative. Now the first derivative has many names, gradient function being one of them. Ultimately, if you were to sub in the value or the x coordinate per se into your first derivative, you find the gradient at that exact point. In this case, we're trying to find the gradient at 0, x equals 0. So f dash of 0 is equal to, I'm just trying to check the equation, so that will be 0 plus half of cos of 0, which is 1, so just a half. And since we know this point P is actually the y-intercept, we can therefore say, well, I don't even have to do y equals mx plus c here. I can just say y equals a half x plus 3, and that'll be that. Lovely. Let's move on. Okay, nice. So we have the trapezium rule next. Okay, between 3 and 4. We're told what the area is, and we want some sort of simultaneous equation for A and B. Okay, sounds good to me. So again, your formula booklet has got the trapezium rule. There you go. There's the trapezium rule. So let's quickly apply this. So this is a very much a numerical question where you have to use your calculator and have to go back and forth. So I'm just going to write down the formula and then I can use the calculator. Okay, cool. So what do we have? So for part A, our trapezium rule area is equal to half a h of y0 plus yn plus 2 times y1 plus yn minus 1. And that's it, right? Okay, perfect. All right, cool. So if we are looking for the so firstly we're looking for the width. Width would usually is the sort of the change, right? It should be a constant width, and it should be the change between sort of your x coordinates, right? So that's 0.2. Because remember, when you draw these trapezium rule, if that was my curve, okay, that's a really bad curve. But if this was my curve, right, we try to do, most cases we'll try to do is a constant width, okay? Just to make the math, I guess, a bit simpler. And at the end of the day, this is an estimation. So yes, you can vary the length of your trapezium, but at that point you might as well just integrate or use a more accurate estimation method. So h is equal to 0.2, and then we have is the rest of the equation. So therefore 17.59, which is what my area is equal to, is 0.2 times a half, so I'm just going to say that's 0.1, y naught, which is a, and yn, which is 13.5. so that's your starting and your ending values of y, and everything else in between will just be 2 times that. 0.8 plus b plus 20.2 plus 18.7. So like I said, it's going to be a lot of using your calculator. So I'm going to head back to my calculator. So I'm going to come back to the regular mode. So what am I trying to do? I'm trying to do is 2 times brackets 16.8 plus 20.2 plus 18.7. And that gives me, okay, so I get 0.1 a plus 13.5 plus 2b plus 111.4. And actually, matter of fact, I should get rid of the 0.1. That's just timesing this side by 10. So that's 175.9. That is equal to this plus 13.5. And that is 124.9. Yeah. So that is a plus 2b plus 124.9, and if I subtract 124 from both sides, I indeed get 2b equals 51, and that is what I was looking for. So again, I'm going to say QED because I proved it. Nice. The next part of the question says, given that the sum of y in the table is 97.2, find the values of a and b. So effectively what it is a set of simultaneous equations. You found your first equation through this is your first equation, and your second equation would be just adding all the elements in the y, and that would be equal to 97.2. so let's add up all the y's. So part B, so sum of all the y elements gives me a plus, okay, so a plus b plus, and I'm just gonna again back out my calculator. Actually I've got 111.4. if I just divide that by 2, that should work. So that is 55.7. Cool. Okay, so actually no, that's not right, because I need to add the 13.5. I was trying to take a shortcut here. Hopefully I didn't make a silly mistake somewhere in there. 69.2. Just as a peace of mind, I'm just going to quickly add up because I don't want to re-record this segment. So 16.8 plus 20.2 plus 18.7 plus 13.5. Please be the same thing. Okay, it is the same thing. All right, cool. So I guess, yeah, so this is now equal to 97.2. 97.2 equals a plus b plus 69.2. So therefore a plus b is equal to, so 97.2, take away the answer to give you 28. Oh, that's a nice equation. I guess so many ways you could solve it. Me being an engineer, I'm kind of lazy, so I'm just going to go and use my simultaneous equation function. So I'm looking at 1, 1, 28, and 1, 2, and 51. So therefore a is equal to 5 and b is equal to 23, and that's my final answer, and that should be equation 2. All right, Nice. Anything else? Okay, no. Let's keep going. Okay, manipulation of logs. Looks good to me. That's A and that's B. Log of base 2. So for the first one, if we have log of base 2 square root of x, my first plan is, if I've got something that's a square root, I'll try to express it as a power. Okay, so log of 2 x to the half. And as you know, with logs to the powers, you usually bring down the power. Okay, so if you have a log of base a, b, c, then you do c times log of base a, b. So if I bring down the power of a half, I get log of base 2x, and clearly that's just a. So that's just half of a. Okay, part B. So now it looks like we got x squared and x inside. So my first instinct would be, let's take an x out and see what happens. So log of base 2. If I take an x out, I get x plus 8. Now we can use the log rule of multiplication, which is equal to the addition. So the rule I'm talking about is, if I have log of ab, that will be log of a plus log of b. So that's the rule I'm going to be using. So therefore I can say is log of base 2x plus log of base 2x plus 8. Luckily for me, those are nice and easily sorted. That's just a and that's just b. Brackets. Okay, should circle my answers. And part C, finally, we have log of base 2 of 8 plus 64 over x. Okay, so here, a couple things we could do. I'm very inclined to find a common denominator and make it into one single fraction. So let's see what happens there. So base 2, 8x plus 64 over x. And now it kind of works out, because now I can use the rule for divisions, and that is equal to taking away. Okay, so log of a over b is same as saying log of a take away log of b. So log of base 2, 8. I'm going to take 8 out again. I want to try to exploit what we done earlier, minus log of base 2x. And I can say effectively what we've done for part B, do that for part C again. We do log of base 2 of 8 plus log of base 2 of x plus 8 minus log of base 2x. Then this is equal to 3. That is equal to b. That is equal to minus a. Oh, that itself is equal to a. So I should get is 3 plus b minus a, and that's my final answer. Nice. Right, so we got functions next. State the range of f. So we know that the x values are strictly greater than 2, but they belong to the real number set. What we can therefore do is find the limiting case, i.e. the smallest possible value that f can take, and anything bigger than that limiting factor would be its range. So what do I mean by that? Clearly the limiting factor would be when x is equal to, well, 2, right? That's the smallest possible value. So if x is equal to 2, yeah, f of 2 is equal to 3 plus square root of 0, which is just going to give you 3. So that just goes to 0. So therefore the range of f of x has to be greater than 3 strictly, because that was the smallest possible value. Next it says find the inverse. Okay, so we start off with saying let y equals 3 plus square root of x minus 2. Now we try to make x the subject. So take away 3 from both sides, square it, I get x minus 2. And x equals 2 plus y minus 3 whole squared. And now finally we can swap the variables. So we can say therefore f inverse of x is equal to 2 plus x minus 3 whole squared. And that's my answer. Next, I have another function g of x, 15 over x minus 3. They want us to find gf of 6. So my idea here would be therefore to find what the value of f is when x is equal to 6, then sub that into g. Okay, that will just save you the effort of finding the combined composite function, which, by the way, feel free to do so. It will just save you a lot of time, because it's a 2 marker I don't think we need to be spending that much time trying to find the composite function and sub it in 6. So instead what we'll do is we'll sub it 6 into f, and then we'll sub that into whatever we get, we'll sub that into g. So f of 6, and what was f? Okay, it was 3 plus square root of x minus 2. So instead of x, we're going to have 6. That's just going to give you 2, right? So 5. And then if you do g of 5, which is 15 over 5 minus 3, that's going to give you 15 over 2. So that is indeed the value you're looking for. So you can see it's a lot more quicker than trying to find the overall composite function. But it's good practice to have a go at it anyway. Cool. So the next one says find the exact value of constant of a for which these two functions are the same. So we can start off by finding what f of a squared plus 2 would be. That would be 3 plus square root of a squared plus 2 minus 2. That cancels away, so I get 3 plus a. And g of a, which would be simply 15 over a minus 3. So if we're saying that these two equations are therefore equal to each other, so that'll be 3 plus a, and I'm going to quickly write this as a plus 3, and you'll see in a second why I'm doing that. Because I'm going to cross multiply a minus 3. So I get a plus 3, a minus 3 equals 15, and this looks like complete the square, right? So not complete the square, differences of two squares. Sorry, I misspoke there. So that should be a squared minus 9 equals 15. So a squared equals 24, correct? And we're looking for plus or minus 24. Now if we come back to the question, it says the exact value of constant of a, so therefore they're inferring that there is only one correct solution rather than two. Which one do you pick as the answer? Now if it's not obvious to you, it will be the positive one. The reason is the positive one is if you choose the negative one and try to solve the equation again, so recreate the problem, try to solve it, you probably will get a different answer than what you'd get with the positive one. So I'm going to say therefore a equals root 24. Now if you're not satisfied with that explanation, what I encourage you to do is again solve the equation, but this time where a, you plug in the value of a here as minus root 24. So you can say that f of a squared plus 2 is going to be equal to 3 plus square root of minus root 24, minus root 24 squared plus 2 minus 2, and g of a is going to be equal to 15 over minus square root of 24 plus 3. Actually, it was minus 3. Okay, so what I encourage you to do is solve these equations again, and I believe that you won't get the same answer as you would if you use the positive. Therefore, we're gonna disregard it. All right, let's keep going. Next one. Okay, so we have a plan view of a stage. Two similar triangles, it seems. And we have a sector in between. Cool. Right, I think all the numbers are given. Okay, yeah, all the numbers are given on the diagram. We're asked to show that OC is equal to 12. So O to C. So that's the radius, right? That's the radius. And we're given the arc length. Then we can therefore find what radius need to be. So we know that arc length is equal to r theta. So therefore r times theta, theta being 2.3, is equal to 27.6. So r must be equal to, what's that, 12? It probably is. I'm not going to bother doing it. Probably is true. Okay, next it says show that the size of the angle AOB, so that's this angle here, is equal to that radians, that much radians. So looking at the situation of the problem, right? Since I know that these two triangles are congruent, i.e. similar to each other, then these two angles must also be the same, correct? And we know the angles on a straight line add up to pi radians. So seems pretty obvious. We'll just take away 2.3 from pi and divide it by 2 to get AOB. So pi take away 2.3 over 2, and that should be 0.421 radians. Again, not going to bother doing it. Probably is true. Okay, next we have the total length of the front of the stage is 35. Okay, so total length, so I believe that includes these two bits, BC and EF. And that is equal to 35. Find the total area of the stage. So total area, that's including the two triangles and the sector. Okay, fine. So what's the plan here? So the plan here is that we figure out what is these two bits, so BC and EF, and we can do so by doing 35 take away 27.6, right? So I'm taking away the arc length from 35, and since these two are equal length, I can just divide them by 2. So if I come back to my calculator, should be getting in the menu. So we're looking for 35 take away 27.6 over 2, 3.7. Sorry. So we're looking at 3.7 centimeters for that. Cool. And if you're now trying to find the entire area, so my plan is I find the area of one of these triangles, and I find what the area of the sector is, then I can multiply the two triangles, add them up, and I get the entire area that I'm looking for. So let's set up how does my triangle look like. So I've got 0.4321, I think 21, sorry, 0.421. What else do we know? Yes, so we know the entire length now because we know what the radius is. The radius is 12, and that's 3.7. So actually that is 15.7, and this length here would be the half of that, half of 15, which is 7.5. There you go. So now we can use the formula for a triangle, area of a triangle. So area of the triangle, so I can say triangle, it would be half AB sin C. In this case, that's half of 15.7, 7.5 times by sine of 0.421. So let's sub in everything. So I want to quickly go to radians just to make sure I'm on radians. Okay, so I'm looking for 0.5 times 15.7 times 7.5 times sine of, oh, I can't type sine, sorry, sine of 0.421. Yeah, so we're looking for 24.0606 for one triangle, so therefore both triangles, so a total triangle would be times this by 2 to give us 48.123 centimeters squared. Now area of a sector, on the other hand, half r squared theta, 12 and 2.3. Yep. So it'll be a half of 12 squared times by 2.3. Let's just put that into our calculator as well. Times by 12 squared times, oh, what's going on? Squared times 2.3. And how much is that? 165.6 centimeters squared. So therefore my total area is going to be 165.6 plus 48.12 dot dot dot. So this plus 48.1213 to give me 213.7. How many decimal places? Nearest square meter. So actually we're looking for 214. So damn it, 214 centimeters squared, and that's my area. So next we have is a geometric sequence. We got the first, second, and the third term. and we need to find some sort of equation. So my first inclination therefore is to find the common ratio. So find an expression in terms of its common ratio. So we know that common ratio would be the second divided by the first term, and should be also equal to the third term divided by the second term. So we're looking for something along those lines. So what do we therefore need to do is we got is 12 minus 3k over 3k plus 4. That's equal to k plus 16 over 12 minus 3k. Right, so now we can cross multiply and simplify everything. So I go 12 minus 3k whole squared equals k plus 16 3k plus 4. Right, so let's expand all of this. So I get 144 minus 72k plus 9k squared, 3k squared plus 4 16, that's like 52, right? So plus 52k plus 4 times 16, that's 64. So let's simplify everything. So I get is 6k squared minus, we're looking at 124k plus 80 equals 0. So now I can divide everything by 2 to give me 3k squared minus 62k plus 40 equals 0, and that's exactly what I wanted. So I'm just going to say QED. Cool. Part B says find the sequence, given that the sequence converges, find the value of k. So firstly we can just like plug it into our formula. So we are looking, so plug into our calculator, I mean. So we are looking for 3 minus 62 and 40. So the first value of k that we get is k equals 20, and the other value, k2, should be 2 over 3. Now the key thing in the question was that the series converges. Now if a series converges, that means that your ratio is between -1 and 1. So ultimately our plan is, let's sub in the value of k, the both k's, we get two different sequences, and therefore we find the two corresponding ratio values, and whichever value is between that range that we're looking for is our ultimate answer. So when k equals 20, what do I get? What are my three sequences? So I have 3k plus 4, I have 12 minus 3k, I have k plus 16. I hope I'm right. Yes, I am. Nice. So if k is equal to 20, just going to move things around a bit. Need to stay there. So my first term would be 64. Then 12 minus 3k, we're looking at minus 48. And then plus 36, right? So if you find what the ratio is, looks like it's decreasing, which is a good sign. We can just divide minus 48 by 64. I think that's 0.75 if I'm not wrong. So let's actually try that out. Minus 48 divided by 64 give us, yeah, minus 0.75. And this is going to be minus 0.75 again. That's why the negative sign disappears. I think that's my answer, but I'm going to still find the other one just for the sake of completeness. 2/3. So the first one is going to be 6. Next one is going to be 10. And I'm never going to bother finding the next one because I look at the ratio. That's going to be 10 over 6, which you're looking at 5 over 3. So that is greater than 1. So in this case, your answer needs to be basically k equals 20. So k equals 20 because r equals minus 7.5, and it's between minus 1 and 1. Okay, nice. So next we've got is find the value of the summation, the infinite summation. Oh, we don't have any more pages, so let me just add another page. Okay, cool. So part 2 of the problem says we need to find the full summation, summation to infinity. So at this point I'll come down to the formula booklet, and there you go. That's our formula, a minus 1 minus r. Okay, so here what we're really looking for here is we know what the r value is, and a is your starting value. Our starting value is 64 for r equals to minus 7.5. So 64, 1 minus 0.75. So let's just put this into our calculator. So now let's come back. So we're looking for a 64 divided by brackets 1.75. So we're looking at 36 point. Do they want the exact sum? No, they don't. I guess we can leave it as a fraction. I don't think it matters too much. So that was 256 over 7. And that's my final answer. Cool. So next we have a circle. We have this equation. Alright, we've been asked to find k, the coordinate. In terms of k, find the coordinates of the center and the radius of the circle. Right, so if you are given the full equation of the circle like it is, like a bit jumbled up, the technique here is always to use complete the square. Okay, we complete the square so we can get two nice brackets. Remember, the general form of a circle, equation of a circle, looks something like this, right? So by doing complete the square, we can actually get them into nice brackets and then therefore tell a circle. So first, I guess the first order of business would be to grab all the x's together. So I get x squared plus 6kx plus y squared minus 2ky, and there's a plus 7 that can just chill there, no problem. And now if I do complete the square on this and this, for complete the square, we have the b value or the coefficient of x. So it'll be 3k whole squared. Then we take away the halved value plus y minus k whole squared minus k squared plus 7 equals 0. So we get is x plus 3k squared minus 9 plus 1. So I guess minus 9 minus 1. That to give us minus 10k squared plus 7. And that's my center. So therefore, that's my radius. Actually, what I'll do is I'll take it to the other side. So this becomes positive and that becomes negative. So therefore, my center is going to be minus 3k. K, we always swap the sign on the inside of the brackets, and my radius is going to be, or radius squared is going to be 10k squared minus 7. I don't think there's a point in square rooting that. You're not going to get anywhere with it. Okay, but since they want the radius, I guess yes, fine, you can square root that, no problem. So this was now let's carry on. So we're looking at part B. We have some equation that intersects at two distinct points, and we're trying to find a range of possible values for k. This is a very big hint that this is going to be some sort of discriminant problem. Where's the hint coming from? The fact that they're talking about two distinct points. So every time they start talking about distinct points, two distinct points, one real solution, no real solutions, find the range of values, that should be a hint that this is a discriminant problem. So the way we could approach it is we can sub in y equals whatever this is into our original equation, and then simplify all of that and take the discriminant from there. Hopefully that ends up giving us some range of values, a quadratic that we can therefore solve. All right, so let's crack on with it. So that will be equal to x squared plus 6kx plus y, which is now equals to 2x minus 1 whole squared, minus 2ky, which is 2x minus 1, plus 7 equals 0. So let's simplify all this. So I get x squared plus 6kx plus 4x squared minus 4x plus 1 minus 2 times 2, that will be 4kx plus 2k plus 7 equals 0. So now let's gather all the like terms, so the x's. So if I combine all the x squareds first, I get 5x squared, and then with the x's I have those terms. So I get is 6k minus 4 minus 4k plus Okay, let's actually simplify this. I don't know why I didn't simplify it first, but that would give me 2k minus 4 plus 2k plus 8, and that's equal to 0. Right, so now we can actually use the discriminant formula. So for two distinct solutions, the discriminant is greater than 0. So 2k minus 4 whole squared minus 4 times 5 times 2k plus 8, and that's greater than 0. So we're looking at 4k squared minus 16k plus 16 minus 20 times 2, so that's minus 40k. Then 20 times 8, that's minus 160, and that's all still greater than 0. So then finally, if I simplify everything again, I get 4k squared minus 56k, and then I have minus 4, that will be now equals to 5. Am I bugging? I think I'm bugging. That's 160, nope, 160, which is minus 160 plus 16, that's 144. No, I wasn't bugging. So 144, that's greater than 0. We can divide everything by 4, but honestly we're going to use a calculator anyway, so we will quickly find the solutions to be 4 minus 56 minus 144. Okay, so we end up getting two solutions for k is equal to plus root 87, so 85, and k is equal to, so that's k1, k2 is equal to 7 minus root 85. Okay, so if I do a little sketch of my solutions, I'm guessing this is positive and that one's negative. Okay, cool. So I have a negative, positive, missed that completely. Okay, cool. So this is my 7 minus root 85, and this is my 7 plus root 85. If I'm looking for an answer that is greater than 0, I'm actually looking for this area right there. So therefore, the value or the range of values we're looking for, k has to be greater than 7 plus root 85, or k has to be less than 7 minus root 85. Okay, actually it shouldn't be or, it should be and. Perfect. So let's carry on. Question 11. Looks like logs to us. Right, we have the value of a phone. We have AB to the power of t. Cool. So we're actually plotting log of the value against t, the time. It passes to 2 points. So find the initial value of the phone. So if you're trying to find the initial value of the phone, what we're effectively looking for is what's the y-intercept, right? In this case, the y-intercept would be log of base 10 v, that's equal to 3. So v is going to be equal to 10 to the power of 3, which is 1000, and that's the initial value of the phone. Find the complete equation for v in terms of t, given the exact value of a and b to 3 significant figures. So at this point, what we can start doing is we can express the exponential equation into a y equals mx plus c form that we can actually see and manipulate in some ways. So if it's v equals a b t, I can take logs on both sides, and I'm going to take log of base 10, and I'm not, since it's log of base 10, I'm not going to write that it's base 10. Then we can get is log of a plus log of b to dt, and then I can bring down the t to give me log of a plus t times log of b. So clearly we can see if we compare this against y equals mx plus c, so this would be c, this would be m, and that would be t. Okay, that's a really bad way to say it, but if I were to rewrite this to be log of v equals t times log of b plus log of a, I can say that this is y, that's m, and that's t, and that is equal to your c. That's your y-intercept, right? So m, we can find the gradient, we can find, we have the 2 points, correct? So we're looking for the change in y over the change in x for the gradient. So in this case, that would be the 2.79 minus 3 over, what was the other? 10. Okay, so that's my gradient. So let's quickly find what my gradient needs to be. So we have 2.79 minus 3 over 10 to give us a value of minus 0.021. That checks out because we're looking at a line that is downslope. Okay, cool. So that's my gradient sorted out. My y-intercept, like we said, is going to be plus 3, right? So c is plus 3. So actually we do have the equation. So that will be log of v equals to t times minus 0.021 plus 3. Okay. Now, if you're trying to find v in terms of t, not log of v, right? So let's take everything to a base of 10. So I get is 10 to the power of minus 0.021 t plus 3. And we can see we can actually make it a little bit more prettier. We can separate the 3 out because we're adding 2 powers, right? Multiplicative powers. So I get minus 0.021 t. So that's 1000 times by 10 to the power of minus 0.021 t. And that's equal to v. And that's my relationship, v in terms of t. Right. So next we've got is how reliable is our model. So we have to evaluate this model. So after 2 years, the phone value was 320. Now key thing here to notice is that t is in terms of months. So if you were to put in 2 in terms of your t, then you're gonna get the wrong answer. So if you start in v equals 2, I get 1000 times by 10 to the power of minus 0.021 times by 24 here. Again, 2 years, 24 months. So let's put all of this into our calculator. Times with brackets 10 to the power of minus 0.021 times by 24. Okay, so that gives me a v value of around 313.33 pounds. Now looking at what the value was, which was 320, I would say we're not far off, honestly, right? We're about, 7 quid off. I think it's pretty reliable. So since 313 is near an acceptable range to, okay, that's not how you spell range to 320, it's reliable. I was gonna say it's pretty reliable, but I would say it's reliable. Okay, let's move on. Next question. Okay, looks like from first principle, differentiation from first principles, those are always fun. And we need to show that y equals sine x can become cos x. All right, cool. So let's start off. So we know the differentiation from first principles. The formula is that dy dx is equal to limit as h tends to 0 of f of x plus h, take away f of x over h. So limit as h tends to 0, f of x plus h, so sine of x plus h, take away sine x over h. So here if we do is if we come back to our formula booklet and try finding the addition formula for sine, x plus h would give us sine x cos h plus cos x sine h minus sine x all over h. So now the idea is that we'll group all the sine x's together, because since we have a takeaway sine x, right? So limit as h tends to 0. If I take a sine x out, I get is cos h minus 1 over h plus cos of x times by sine of h over h. Now there's a reason I wrote it like this, because I'm looking at the question, and as you can see in the question, we have sine of h over h. That will tend to 1 when h tends to 0, and this bracket will tend to 0. So therefore I can say is that this will go to 0, that will go to 1, so I end up with cos x, and that's my answer. Let's carry on. So we have question 13 now. Looks like it is to do with a roller coaster of some kind, and we've been told the modeling, and it's a quadratic modeling. We've been told the maximum vertical height is 60 and the initial height is 2 meters. Okay, cool. So we need to find the complete equation for the model, i.e. they're asking us to find what the values of a and b are, those being constants. Okay, so we can exploit the fact that we know the maximum vertical height is indeed 60 meters, because given that it's a quadratic, we could find the corresponding x maximum point, if that makes sense, because it's a completely square situation. So we can say that at t equals, which would be 20 in this case, remember you swap the sign on the inside, so at t equals 20 second, h is equal to 60 meters, right? And if we sub in those numbers, so 60 equals a minus b. Now this would be 20 minus 20 all squared. That goes to 0, so therefore a is equal to 60. Then what else can we use? We can use the fact the initial height was 2 meters. We could exploit that fact, so we can say at t equals 0, h is equals to 2, and that gives me 2 equals a minus which would be 60 minus b, b being well, b is what we're trying to find, 0 minus 20 whole squared, so therefore b is going to be equal to minus 58 over minus 400. So if I just pop that into my calculator, what do I get? Minus 58 divided by minus 400 to give me an answer of 0.145, and those are my constants. I'm just going to circle those in, and h is equal to 60 minus 0.145 t minus 20 whole squared, and that's my final answer. Okay, question part B, it says determine the model of the height if t is equal to 40. Pretty straightforward, we just sub in t equals 40 and see what the answer we get. So therefore, well, h is going to be equal to 60 minus 0.145 20 whole squared. Pop it into our calculator again, 60 minus brackets 0.145 times by 20 squared to give us an answer of 2 meters. Okay, cool. Right, next it says now we have some kind of trigonometric model of it, and again we're asked to find the complete equation, i.e. find alpha and beta again. Okay, so I think for alpha I have an idea, beta is less so obvious, so let's have a think about how we can find beta. So looking at our equation, beta is effectively the midline height, or the vertical height that is shifted up. So you have the normal cos graph, and if you remember the normal cos graph, no matter what kind of transformation you do to it, it will always cross the axis. Now if you think about it in terms of a roller coaster, hopefully a roller coaster doesn't actually intersect with the ground. Okay, so in this case, that's why we shift it up by some beta amount. So my idea here is we can approach it either from a maximum height point of view or a minimum height point of view. So if we think about it in terms of the max height, for us to hit the max height, this thing has to equal to 29 plus beta, and we know what the max height is, which is 60, right? So effectively that's the equation we're solving. So so max height cos of 90 plus alpha, whatever that is, has to equal 1. So I get 60 equals 29 plus beta, so therefore beta is equal to 31. Now for finding alpha, I think it's a bit more straightforward. We could use when t is equal to 0, height is equal to 2. So at t equals 0, h is equal to 2. So 2 equals what's my equation? 29 cos of 90, I guess cos of 90 plus alpha minus 31. It's minus, right? It's plus. Okay, so it's cos of the entire thing. My bad. Should be a bracket here. Okay, cool. So t is equal to 0, so this goes to 0. So what we end up having is minus 29 is equal to 29 of cos of alpha. Well, therefore cos of alpha must just be minus 1, so alpha must be 180, because if we were to sketch the curve, minus 1 is at 180 for the cos. Cool, so let's keep going. So we found alpha beta. Next question is asking for, give a reason why the alternative model would be more appropriate if it moves for 2 minutes continuously. Well, it's to do with roughly how the both functions look like, right? One of them is a quadratic, the other one is a trigonometric. Now the trig one has an inherent advantage because it's a cyclic. So it cycles through. Yeah? It's a periodic function. Whereas the quadratic, on the other hand, because it's a negative quadratic, it's just going to swoop down. So what we expect to see for the quadratic, we start at initial height of 2, we hit the max height at 60, then we come down and we keep going down. That's no good, because you're just going to go hit the ground, you know, if you're on a roller coaster. Versus if you have the cosine, we shifted it up by some beta amount, right? Because we shifted up by some beta amount, effectively now we can make sure that it oscillates through the up and down and giving you that sort of the classic how a roller coaster works. So model B in this case, or the trig model, is definitely the better one. Okay, so now we have to prove using algebra that this expression is odd for every value of n, or when it's natural numbers, I guess. So best way to prove this is if we start off by seeing how is the odd numbers case look like and what's the even number case look like, because if we cover both odd and even cases, that means we've covered all the natural numbers that there is. So let's start if n is odd. So if n is odd, then n is equal to 2m plus 1. Actually, you know what, let's use the letter k. I like k more. So that will be 2k plus 1 cubed minus 2k plus 1 cubed. Okay, so that's 2k plus 2 cubed minus 2k plus 1 cubed. And it looks like we got ourselves a cubic. And obviously you can... there's cubics. When it comes to cubics, you could either treat it as a quadratic and a linear factor. So you expand your quadratic, times it with the linear. I'm just going to just use the binomial binomial theorem, sorry. So I'll just quickly make my Pascal's triangle. These are my coefficients that I'm looking for. So 2 cubed to the power of 3 plus 3 times 2k squared times 2 plus 3 times 2k 2 squared minus 2 cubed. So plus 2 cubed. And I'm going to put these in one bracket and then take away. On the other hand, we'll have 2k cubed plus 3 times 2k squared plus 3 times 2k 1 squared plus 1. Okay, clearly I can just get rid of these two out of the way right away. Now let's expand everything else. So this term right here, we have 6 times 4, which is 24k squared. This term is going to be 4 times 3 times 2. So 6 times 4 again, so 24k. Plus 8. Take away. This case is going to be 4 times 3, that's 12k. Plus 6k, that one squared. Plus 1. So now let's take away everything. So I get 12k squared. Minus 18. Sorry, plus 18k. And we have is plus 7. Now we need to have it in some way so that we have a factor of 2 being taken out and we have plus 1. So what we could do is this 7, we could rewrite it. So we can say 12k squared plus 18k plus 6 plus 1. And then if I take a 2 out, I get is 6k squared plus, what would that be, 9k plus 3 plus 1. and I can say that clearly this is going to be an odd number, right? It's in the format of, if you let this be some other dummy constant variable, it'll still be odd. Now let's look at if n is even. So n is equal to 2m. Actually, let's use k again. So my expression was 2k plus 1 cubed minus 2k cubed, right? Yeah, plus 1 minus. So actually we did expand this already, so I'm just going to copy my answer from question above. So it was, so the only term that's missing would be the 8k cubed one, plus 12k squared plus 6k plus 1. I guess in this case it didn't matter at all. I was going to cancel each other out. So 12k squared plus 6k plus 1. And if I take a 2 out, plus 3k plus 1, and clearly that's also odd. So we just proved both ways, whether it's an odd or an even to begin with, it always ends up being odd. Right, that's a long question. So we have some curve, we have its function, we will need to show its derivative. 5 marks. So that tells me there's a lot of simplification, or let's say, yeah, a lot of factorizing and simplification to be done here. Okay, so right, so I'm just gonna write down what the question is. So it's f of x is equal to 7x e to the x square root of e to the 3x minus 2. Cool. So I hope you can recognize that this is a quotient rule problem, right? Because you're trying to differentiate a fraction, and you usually use quotient rule. Technically, you could get away with product rule if you were to bring the denominator as a power of -1. At that point, you might as well just do quotient rule. Okay, so what are my rules? It's u over v is going to be equal to vu dash minus uv dash over v squared, and the product rule is uv equals u dash v plus v dash u, I guess. So I think what might be more beneficial, or might be a bit more cleaner, if I were to just differentiate both of my numerator and denominator ahead of time, it would just probably save me a lot of time rather than doing it in one go. So if I differentiate ddx of 7x e to the x, that would simply be 7ex plus 7xex using the product rule. And if I differentiate my denominator, e3x minus 2, so that would be a half of e to the power of 3x minus 2, the whole thing to the power of minus a half, times by 3e3x. And that one's coming from using the chain rule. Okay, so firstly, I think what I should say is this thing raised to a power of a half, right? You bring down the power, take away 1 from the power, then you differentiate what's inside of the brackets. Right, I guess I can just write this a bit more cleanly. Right, let's see how we can get along with this question. So we've differentiated both our numerator and denominator separately, just thinking that it would help us. So now try using the quotient rule for differentiation. So f dash x. So we're doing v stays the same, which is e3x minus 2 to the power of a half, times by u dash, right? And my u dash, I already figured it out what that is, which is going to be 7e to the x plus 7x e to the x minus vu dash, so v dash u, so that's 3 over 2 e to the 3x, e3x, I don't think I'm going to have space, so what I'm going to do is I'm going to get rid of this and just try to shove everything to the corner, because I actually need to write everything on one line. E3x minus 2 to the minus a half times with, what was my u? So my u was 7x e to the x. And all over my denominator squared, which is going to be e3x minus 2. Okay, interesting. So I'm just going to put some brackets around the negative. What could I do from this point? I am looking at the, so I'll back out the laser pointer. I'm looking at this expression that is minus a half. And I have a plus a half. And I have the same thing that is to the power of 1. So I'm thinking, why not times the denominator and the numerator by this expression here, right? It just gets rid of one expression. So let's try do that. So I get e to the 3x minus 2 now, because a half and a half, and then 7 e to the x plus 7x e to the x minus 3 over 2. I guess let's times it by 7, so let's say 21 over 2 e to the 3x, and times with x e to the x. I think I'm probably just gonna simplify that a bit more at some point, and I'm gonna get e to the 3x minus 2, all to the power of 3 over 2. So at this point I'm gonna double check my answer. Okay, so it looks like there's a 2 in the denominator, and I've got a good idea where that's coming from, and then that's 3 over 2. That was the right call to make. So there's 2 in the denominator, and I'm guessing what that would come from is that 2. So let's just times everything by 2 to get 2e3x minus 2, 7e to the x plus 7x e to the x minus 21. I'm going to say 21x e to the 4x over 2 times e to the 3x minus 2, 3 over 2. Okay, so now let's carry on. So what can I do from this point onwards? I'm thinking we could try taking this e to the x out. I guess with the 7 as well, right? We can take out the 7 e to the x. That's common between those two. I guess we could take those out and see what happens. Yeah, let's give that a go. So that becomes 14 e to the x of e to the 3x minus 2 times with 1 plus x minus 21x e to the 4x all over 2 times e to the 3x minus 2, 3 over 2. Now what we could do is, matter of fact, what we could have done was we could have pulled this out of everything, because I can see that this, yeah, since I can pull the 21, I have a factor of 7 in there. I tell you what, let's pull out of everything. So rather than why stop here, so if you do 21, we're taking a 7 out, so we should see a 3x, and we're taking e to the x out, so we should say e to the 3x. Okay, so now what we could try is we could expand that, simplify it. Hopefully that takes us somewhere. And I'm just going to double check the 14. What's the situation with the 14? Okay, it does turn into 7. I have a 14 at the moment because I had a 2 there, right? So when I pull a 7 out, 7 times 2, that'll give you 14. But okay, we'll see. We'll see what happens to that. If I expand everything inside of the brackets, I get e to the 3x. Actually, you know what? What I'm going to do, because that was 7, what I'm going to do is I'm going to say this is 7, and I'm going to put a 2 inside of the brackets. Okay? So I'm going to say 2 e to the 2x minus 4. So that's one bracket. So I'm just going to times everything on the inside. Minus 3x e to the 3x. Okay? And I think this is what I really enjoy about these type of questions. It's like it's going back and forth, and you're trying to do problem solving to figure out what's the sort of the right direction to take. There's no right or wrong answer here, really, because it's just all simplifying. You probably like I could submit this as is, and this would be, well, factually correct because I differentiated correctly. However, they want it in a specific format, so I'm trying to go back and forth, trying to figure out what's the best combination or the best path. So now if I expand everything, I get 2 e to the 3x plus 2x e to the 3x minus 4 minus 4x minus 3x e to the 3x. Now I think I'm getting very, very close to the answer, which is rather promising. So now let's simplify and clean everything else up. We have this minus 3x that could go with this, and we have 2 e to the 3x minus x e to the 3x minus 4 minus 4x over 2 e to the 3x minus 2, 3 over 2. Now let's check our answer. Okay, looks like they just pulled e to the 3x out. That's exactly what we're looking for. And there you go, that's the answer. So 7 e to the x, e to the 3x to give us 2 minus x minus 4 minus 4x over 2 e to the 3x minus 2, 3 over 2. And there you have it. Like I said, it's just about going back and forth, checking your answer constantly against what they've given you to see, are you going in the right direction or not? If you're not, always try to change course. Maybe think about another way to go about it. Part B. Show that these are the turning points. All right, so we found the derivative, so we can just set it equal to 0, I guess. So we can say part B, f dash x is going to be equal to 0 at the turning point. So therefore 7 e to the x. And by the way, like, even if you didn't get to the answer that they've given you, nothing's stopping you from doing the rest of the question. I think that's why they kind of given you the answer, because it was a show question. So they've given you the answer and said, hey, you might get this, you might not. If you don't, like, carry on with the rest of the question, right? Nothing's stopping you from taking that answer. You just won't get the full marks for part A if you didn't show the whole working out, but you can pick up the marks for B, C, and D, right? So, you know, you should always try to do as much as work as possible. So that's equal to 0. We can cross multiply to get rid of the denominator, and also the numerator, the multiplication, because everything's 0, right? So I can times by 0, goes away, divide by 0, goes away. So I end up with e to the 3x 2 minus x minus 4 minus 4x is equal to 0. So what do we want? Again, I need to double check the answer constantly. So we want to make x the subject, I guess, yeah. So we have an x here, we have an x here. So let's gather all the x's on one side and shove everything on the other side. So I get 2 times e to the 3x minus x e to the 3x minus 4x equals to 4. And if I take 1 second, that's positive, right? So okay, so you know what I'll do is I'm going to keep that as negative here, make that equal to 0, take everything to the other side. So I said 2 e to the 3x minus 4 is equal to x. I'll take a common factor out to give me e to the 3x minus 4. So therefore x has to equal 2 e to the 3x minus 4 over e to the 3x minus 4. And that's what we're looking for. Okay, part B done. Part C. Okay, so it's turned into iteration now. Fine. That's our iteration formula. Diagram 1 shows the plot of the curve. Diagram 1 is on page 42. Use a staircase diagram to show, starting from 1, how you can find the approximation for B. B being the other solution, correct? Yeah, so B is greater than A. Sorry. There you go. So if we start at 1, we go to our curve, right? We go to our curve, then we come back to our line, go to the curve, come back to our line, and then that's how we get closer to our solution, and therefore the staircase shape. Okay, so that's C done. Use the iteration formula starting when x equals 1, find x2, so the next iteration, and beta to 3 decimal places. So cool. So what was the formula? Is it the one we just figured out? Let me just double check the signs. Yeah, so this should have been a plus, that should have been a plus. Makes sense, because I took it to the other side, that would have been a plus. So apologies for that one, just double checked. I should always double check my answers actually. Okay, cool. So C we done. That's DI, I believe. And keep count. Okay, it is DI. Cool. So the way to go about iteration, the easiest way is you set it all up in your calculator. So our first guess, x1 is equal to 1. So I'm going to press 1. I press equals. So now when I press answer, that's my answer. So what I'll do is I'll set it up how the expression looks like. guess I'll use brackets because it's kind of a complicated expression. So E, I'm looking for exponential, so that will be shift E. That's 3 times the answer. Okay, so wherever you see an X, now you replace it with the answer button. Then minus 4. Then e to the 3x. Shift E to the 3 times x, which would be the answer. And then plus 4. So our x2 would be 1.501. They want 2 decimal places, 502 to 3dp. Now they also want a beta. So for us to find beta, basically what we're looking for is we'll just mash the equal button a few times, and we'll see at what point does the 3rd decimal place stop changing, and therefore that is us converging. Yeah, I think that's good enough, because the one before was 197,957, 967, maybe one more. There you go, 67. So that doesn't really change anymore. So actually, we could even go one more. Oh, 68. Actually, yeah, it is 68. So beta is going to be 1.968 to 3dp. Okay, last question. Using a suitable interval and a suitable function, show that the alpha is equal to this, to 3 decimal places. So effectively what they're really asking you here is, if you think back to GCSE iteration, we say that there is a solution exists if the function is continuous and there is a change of sign. Okay, so it becomes, it goes from either positive to negative or vice versa. Then we can say that there does exist a solution. So in this case, since what's our interval? 432, sorry, that's our answer, 432. So, sorry. So f dash of 0.4315 and f dash of 0.4325. And we sub those in, and this is going to take a while to put into my calculator. So this is where I'm going to do a little skip, and I'll join you when I have the answers. So now you can see I've got the answers for the 2 limits, if you will, or 2 ranges. And you can clearly see that one is a negative and one's a positive. That means clearly there has been a change of sign, and because we subbed it into the derivative, it also proved that we have a continuous function. So therefore we can say that confidently, therefore alpha equals 0.432. Yeah, 432, right? Yeah, that's it, to 3dp. Okay, perfect. Well, that being said, I hope you enjoyed the video. If you did, please do like the video. We're still a very new channel, so any new likes, any new subscribers can really massively help us out. If you are looking for some more personalized help, we do offer world-class tutoring. So if you're interested, please check us out. Our website will be in the description, and also the notes, so the annotated notes from today will also be on our website. Again, I'll link that in the description and you can find it. But that being said, I'll see you in the next one.